Hey there, everyone. Thank you for checking my asset and welcome to this video explanation of what you can expect in the package and kind of overview of how it works so you can get a clear idea of what to expect from the functionality. So going into Unity, we're going to start by just taking a look at the assets that I do have in the scene. So once you download the Unity package, it's going to be these folders here. So we're going to start off by showing what's going to be in the package itself. So right here, you can see it'll be in the SD assets folder in Dutter assets, and then the eye tracker. I may change that to eye parameters, but for right now it's eye tracker. Now, it has a few folders. The most important setup is just this here. So you have your blend trees that are just empty blend trees here. Once you plug it in, you have spots to include motion clips, and then it already has the correct parameters assigned. So this one's just 4 directions, and this one's for 8 directions. Basically, this one has smoother movement, but requires more animations, and this one is the simplest but has a little bit more angular movement as the eye moves around. And then in here, this is the scene you're looking at. We have this eye tracker example scene. That's the one you pop over here. And these are all the assets that I put together to create these. And the prefab itself is just this object right here. If we go to the example assets that I've made, so you want to think about these as VRChat avatars. They're just a set of eyeballs floating in the air, but that's what they are. And we have rotation states set up, so it's very easy to test if it's working. But at the root of each of the avatar is the eye tracker prefab. This is all you have to do to get it working. In terms of adding the app to your avatar, there's more work on the animator side, but when you want to get the eye tracker into your avatar, you just drag and drop it onto your top level object, and that'll fix it right here. And you can see for each of these avatars, one avatar, two avatar, we have one tracker for that one and another tracker for the other one. Now, sometimes this is just a little bit finicky. But sometimes the rotation states, when you're testing them, they will then put the eyes off to the side. Basically, they'll keep the rotation value on this eye bone L. And you can always just go into the tracker prefab and reset it. Right now, I don't have it because I've prefabbed the whole thing, but you'll see it should look like this, these overrides. You can basically just reset the overrides, but for this little prefab. Now, for the prefab, let's go ahead and take a look at it directly. So let's drag this one out. I'm going to zoom in on it. In fact, let's hide the plane just so we can see this. So this is what we're looking at with the eye tracker. It's a little bit hard to see just because the gizmos are so small. But basically, at its core, it's 2 capsule colors set up as an X. Actually, this one is the Y value checker, even though it's horizontal. It checks the Y direction. And this one is the X checker. You can see I have the X1 right here and the Y1 right here. Now, there is a bone here, and it's kind of offset. So if we select all of them, you can see the capsules are here, and the bone is a little bit off to the side. In fact, it is exactly lining up with the edge of the capsule. And then, lastly, we have our origin object, which is a contact sender. These objects are contact receivers, and they receive this eye value from the sender. And basically, these are exactly the same, the X and Y contact receivers, just the orientation is different. But most importantly, they output to the EyeX and the EyeY parameters, respectively. Now, for the origin, this one just says eye. These both receive it eye, but output EyeX. Now, for how this receiver works, it's basically the proximity here. So how far away is the sender from the center of the capsule? And that's kind of the key insight here, is that with the origin um, set in the middle of the subject, we know based on how far it is from the center, which is the center line on the capsule, it is to the center. So right here, it's at 0.5. That's what I started at. And it makes sense, right? Your eyes are in the middle of your eyeball, or your iris is in the middle of your eyes, looking straight and then off to the side. So we have that as our origin or our center. And then it moves up to 1 or down to 0. Now it's a little bit confusing to see in here. I did actually make a little Blender illustration of the same thing. So this is the representation of kind of what's going on and how it becomes useful, and we can derive 0 to 1 parameters from these movements. So here is kind of the same setup. We have our capsules with the center line. So you want to think of this line as 1 for the X sensor, and this one as 1 for the Y sensor. And it makes this nice little grid, which in fact I have actually created a grid representation for. And so this sender is basically moving along a grid, x-axis and y-axis. So you just think of this nice little setup here. And as we move the bone, the sender, the little small sphere, is tied to the bone using, I believe it's a parent constraint or position constraint. And what it does is as the bone rotates, it simply moves up and down. And it's important to note that it's only moving up and down. It is not rotating. It is moving up and down. So if I push it out further, you see how, or rotate the bone further, you see how it still stays along the plane. And that's very, very useful in order to make sure that it's always giving a very consistent value. I needed to put the position for X as well. So yeah, so you can see it can move along this plane within this these two capsules, and this is what gives us our coordinate system. There's a little bit of difference. One small difference is just that if we go look at our example here, this is not exactly in the center of our grid here, and that's just in Unity. And that's because I have offset our capsules by this last 5 here is the size of our context center. And by creating an offset of the receiver based on the radius of our sender, that gives a really clean 0 to 1 value. Yeah, so that's basically how we have it set up. And that's what you can expect to get. Now, kind of did this backwards to how I kind of wanted to initially, but now let's get into just the animators themselves so you can see what's going on here. And for this, I'm going to deliver a tracker, and we're going to look at the FBX files. So once we have that in there, once we have the tracker in scene, what we need to give our character is an FX layer, right? We need it to drive our animator. So I have a series of animators. These ones here are just for my examples, and these are what you can pull out. So let's go to the layers. You can see I have the 4 directions. So again, this is the more diamond-shaped one, and this does actually pretty accurately reflect the kind of movement you can expect from just these 5 positions. We have the center, up, left, right, and down. So those are the 5 positions. And as we move this around, it'll trigger different ones. So let's see if we can actually grab one of these. And then of course we have the 8 direction ones. Right now I'm in the blend shapes version, which is the one with the black eyes. This one's a shader. The main difference between these is that in this version, we're driving a blend shape value. So if I go to the mesh, you can see on our skin mesh render, we have blend shape values. And this is what we've created animation clips for and allow us to move the eyes around. When I'm in its blend tree, we can, of course, trigger them. I have to enter play mode to really get it to work. Or when we go into play mode, it's going to use the. That's fine. Move the game view down here. Okay, so for our avatar, right now, if I'm changing the blend shape of this character directly, it does interfere with the avatar descriptor trying to move these eyes around. So we can preview things like moving the eyes up and down, and left and right. I think when you're testing it with these values, always return it to the middle because it will kind of offset it sometimes, which is easy to fix, but just be aware of that. And then looking at the blend shape itself, or the blend tree, should be able to move this value around. So it's kind of interfering a little bit with what the VRC is doing, but you can see within this space, I can move around the eyes. And yeah, so the X moves this along the X axis. It's important to note that left and right I've set up from the avatar's perspective. So it's left, as in the avatar's eyes are looking to its left, and its right, up, down. Up, down doesn't matter, but left and right. So just keep that orientation in mind. It is from the view of the character, which is how VRChat sets it up as well. So there should be some consistency there. All right, so now we're going to take a look at our shader version. So this is pretty much, again, just the exact same thing. We got our 8 directions set up here, which I do recommend using the 8 direction one. There's more to make, but it's pretty minimal. And still, it gives you much smoother movement. We'll show you the 4 direction in a little bit. But so yeah, you can see I'm moving this around in the same way, left, right. And again, that flickering is just because the avatar descriptor is interfering with the animator. It's basically doing its job. And we're just kind of sticking our hand in the machine, so to speak. And if we go down to the preview straight, looking up. Oh, sorry, that's a blend shape one, shader one. So looking up, looking down, left, right, yada yada. So the biggest difference between this version and this version is that in our shader version, it is driving the material. So on our shader, this is the blend shape version. We can see we have those blend shape values, but if we go to our shader version, it has no blend shapes. And instead, we are animating these X and Y values. So the shader one is most likely going to be less common because you do need a custom shader in order to make this this integration. Most likely, most people buying this package, you will be using blend shapes. But if you're experienced creating custom shaders, or you know someone, or you make it yourself, basically you just want to create EyeX and EyeY values. I'm not going to get into the shader in this right now, and I can't adjust it myself because I have to do it from the outside. Avatar descriptor, eye look, move it around, yada yada. But I like to set them up similarly, so it's just a -1, 0 to 1. Let me actually exit play mode so we can look at this a bit more closely. So -1 for right on the x-axis, 0 centers it, 1 for left, and then of course the same for y. 1 being up, -1 being down. 0 being the center. Um, so I've created these parameters. Technically, it doesn't matter what these are, and one of the great flexibilities of just Unity in general is you can drive any type of animation with these values. Right now it's set up for eyes, but you could totally do anything. Um, but I like using these kind of conventions because it's easy to understand. Um, yeah, so that's about it. Oh yeah, just and again in our folders, I have the 4 directions here. So you can use a simpler version of the blend tree, and then a more complex version of the blend tree. Um, Now the motions here, if you want to see what's what, you can just click on the dot, and that'll let you know which is which here in your list. So you're like, okay, I want to use the center one. Oh, I didn't know you could move them. Don't move them, but just click them. So if you just click them, it'll show you which one's which. So center, then we got the left right there, right, yada yada. You get the picture. So just click on them to find which one's which. But just to be a little bit more specific than that, in our blend tree here, if we click this, actually I should do the 8 direction one. I have it in this order: up, left, forward, right, down. So the first ones are the main cardinal directions. So up, left, forward, right, down. And forward being the center perspective. And then I have the corners here. So up, left, up, right, down, left, and down, right. So, oh yeah, and then of course you could also just click the motion clip itself to see where it is in the position. So pretty easy. Should be a little straightforward. Uh, yeah, and that's pretty much it. If you have any questions, you can always reach out to me on Twitter. I do stream pretty much every weekday from 9 a.m. to 5 p.m. Central Time. So I'm very available, and I would love to assist you if you encounter any problems or have any questions. I'm pretty proud of this asset. It is based on the work of other people who have tried very similar things. But like I was saying in my Gumroad page, I think one of the main advantages I've found is that there is no jitter from my system. When I've seen other people set it up based on the positioning and the effect of movement on the prefab, on the eye tracking system, it will create jitter, which is really odd. It's almost like a saccade, I believe that's the word, a little jitter in your eye, but it gets really, really intense in some moments, and then it's almost not there. It's other moments, but and with my system, it's just gone. And then in my system as well, the way I've set it up, that offset thing I've mentioned, there is just a 0 to 1 parameter. In other systems, you might have a little bit of, it's like 0.999 or 0.95, or it only goes down to 0.1. Mine should always be just a 0 to 1. And of course, there's no need for the open sound control. Most point, I'm saving you a little bit of time. So I know it costs money, but I think that if you are familiar with VRChat and you're looking to make your own, everything I've described in this video should give you a pretty clear understanding of how to put this together yourself, if so inclined. But I'd love your support if you're interested in purchasing the package. Anyway, thank you again for your time. I hope you're all having an amazing day, and I'll see you later. Bye, everyone. Bye.